Okay, let's look at the homework 1, problem number 4. Alright, so what we want to do here is we want to use a comparison test to show that this series converges. Alright, so let's do that. So first, let's look at this guy right here. So this is our AN. Alright, so we have to come up with something to compare with. So AN is 2 to the n minus 1 over n times 3 to the n minus 1, right? Then we have to come up with something that we compare with, and hopefully something bigger than this guy, right? Then we notice that there's an n right here. What if we get rid of that n to make it a little bit simpler? So we can write it as 2 to the n minus 1 over 3 to the n minus 1. Right? So since n starts from 1, so n is bigger than or equal to 1. Right? So if you take away something bigger than or equal to 1 from the denominator, which makes the denominator smaller, right? Which means that the whole fraction is actually larger. So we know that we have a larger one here. Right? Here we can probably write it as, since you have a n minus 1 power, n minus 1 power, we can probably write it as 2/3 raised to the n minus 1 power. Right? So we can call this guy Bn. Right, so this is someone to compare with. All right, then think about the series. So summation, n goes from 1 to infinity, and a Bn is now, you have 2/3 raised to the n minus 1. All right. And you notice that this is actually a geometric series. So this is a geometric series. Right? So this is a geometric series. So all you really need to know is identify A, and A is the first term, and R. Right? So you can see that the A is going to be the first term. So you just plug in n equals 1 because that's the first term. So it's 2/3 to the 0th power. So A is going to be actually 1, right? And R is going to be, every time you increase the value of n, you're multiplying by 2/3 to get to the next term. So R value is 2/3, right? So we know that the if you take the absolute value of R is of course 2/3, right, which is smaller than 1, right, which makes this guy convergent geometric series, right? We even know the sum is going to be 1 over A over 1 minus R, so it's 2/3, right? So that's going to be 1 over 1/3, so that's going to be actually 3. Right? But anyway, we don't need to find that. Since Bn is something larger than An, its series is convergent. By comparison test, the smaller series is going to be always also convergent. So therefore, we know that the summation n goes from 1 to infinity of 2 to the n minus 1 over n times 3 to the n minus 1 converges by comparison test. All right, that's it. I hope that this was clear.